Jupyter notebooks are a very powerful tool to learn about programming and also to communicate scientific results and the methods behind them. What we're seeing here is a notebook by the LIGO Observatory, which detected gravitational waves in 2015. And in this notebook they're showing us how they created some of the figures that they're showing in their paper. And now the cool thing is we can not just look at the plots, but we can also recreate them. And for that we'll have to run some of these code cells. So in here we run that to download the necessary files. Then in the next cell we'll import the necessary Python modules. Then run some calculations with the data. And then when we run this cell here, we're getting one of the plots that are also present in the paper. And now because we have all of the code and also all of the data that is plotted, we could, if we wanted to, change the way the plot is looking, or we could replace the data with our own. So let's make a small change. In here we're adding a title to our plot, and we could concatenate to these strings our own. Let's say we add a smiley face. And then we run this cell again, we also run this cell, and now we have the normal title plus a smiley face. Of course, that's not the most practical application, but you can imagine how useful this is for understanding code and for communicating code and also for making code dynamic. So we don't have to run the whole script again that calculates everything in these upper cells here, but we just make a small change to the plotting cell and we get a different output. So by breaking down code into these smaller pieces, we can improve readability and also we allow for a more dynamic workflow. Now, while we're in this notebook, you might have already noticed cells that are not code. And I'm not talking about these plot images, but about these texts here. And if we double click on one of them, we can see that this is just plain written text. And sometimes, for example, if we double click here, we can see some special characters, for example, the hashtag here, which is part of the markdown language that allows us to add some formatting to our texts. And so then in combination with the code cells, these markdown cells allow us to structure the notebook and explain what's going on in the respective code cells. Okay, so notebooks are great, but how can we work with them? And for that we have two options. Either we install JupyterLab or Jupyter Notebook. And the official Jupyter page also recommends JupyterLab first, because it does offer more functionality, looks better, and is also easier to work with. You can imagine that the normal Jupyter Notebook application is more of a text editor, while JupyterLab is more of an IDE. So here it's, for example, easier to work on multiple files, to debug, set breakpoints, and so on. Now installing JupyterLab can be simply done with pip install. So when you open your terminal, you should make sure that you're in the right conda environment. I will create a new one here. Then I'll run conda activate to activate the environment. And now we simply run pip install JupyterLab. Okay, then let's navigate to an empty folder. And then in this empty folder, we'll simply run JupyterLab. And this will then open this new tab in our browser. And if we check out now the terminal, we can see that a Jupyter server has been started. And if we close this server, so we close the terminal or we hit Ctrl+C, then also the Jupyter application in our browser will be closed. So the server should always be running as long as you want to work on our notebook. The settings here you can explore on your own. We will quickly check out the shortcuts. And the most important shortcut will be the shortcut to run a cell, which can be done by hitting Shift+Enter. Okay, so let's close the settings, and then in here we have the option to either create a Python notebook, a Python console, or something else, for example a simple text file, terminal, markdown file, or also a normal Python file. And because we ran Jupyter from a conda environment with Python, we're only seeing Python here. But Jupyter also supports other languages. So actually Jupyter stands for Julia, Python, and R. So we could also have an R or a Julia notebook. And the language we're working with will always match to the kernel. So in here we have a Python 3 kernel, which means we can run Python 3 code. So let's click on here, and now we have a fresh notebook. We can change on the bottom here to simple, which makes everything look a little bit cleaner. And then we can go up here to change the name of our notebook. Let's call that test notebook. Then press enter, and now we have renamed our notebook. This here is now our first cell, where we can write any Python code that we want. So let's create a variable called a, and we assign to that an integer, let's say 2, and then we can run this cell either by pressing the play button here, or by hitting Shift Enter. And now we notice a few things. So first off, we immediately created a new cell. And that is because we executed the last cell of the notebook, which then immediately creates a new cell. So if we were to run that cell again, then it's not creating a new cell. And the other thing that we notice is that there's a small number next to our cell. And this keeps track of the order in which cells are executed. So this is now our second execution. So we have a 2 in here, we can run it again, then it changes to a 3. And if we write something in our new cell, let's say b equals 4, then this will be the 4th cell execution. And now the cool thing is, once we have run any code, then we can use the variables in any cell. So we can write in here, we print a plus b, we run that, and we get 6. And it gets even more convenient because the last line in a cell is always printed or displayed. So that means we can get rid of the print statement and just write a plus b, and that also gives us 6. As we run these cells, there's something we should look out for, because if we down here assign a new value to our a and run that, then this also will change the a plus b. So now a is 0, so then 0 plus 4 equals to 4. And this is not what we would expect from a normal script. So in a normal script we define a here, b here, and then this a wouldn't be affected by anything that happens afterwards. But because we run this cell and then we rerun this cell again, a, and so also the result gets updated. Okay, so much for the code cells. If we want to create a markdown cell, we can simply go to the top here and select, instead of code, markdown. And then in these cells we can write plain text, we run that, and we can see our text. Now if we want to create a heading, we can use 1 hashtag for a big heading, and 2 hashtags for a smaller heading, and also 3 hashtags or even 4 to make it even smaller. We will not go into any more markdown details, but there will be some resources linked if you're interested in how you can make your notebook look more organized or fancy. Okay, so the next thing I want to show you is the exclamation mark command. And it's important we run that in a code cell and not a markdown cell. And this exclamation mark will allow us to run terminal commands. So for example, we could write as we would write in a terminal, conda list, we run that. And we can see all of the packages that are installed in our test environment. And this can be useful if we, for example, wanted to import NumPy, but it says NumPy not installed. So we just run pip install NumPy, and then we can successfully import NumPy without having to close this Jupyter server and installing it from here. Okay, next up are magic commands. And to indicate that we want to use cell magic, we use the percentage sign. So everything after that is interpreted as magic. And to see what kind of magic we can do, we write ls magic, run that, and we differentiate between line and cell magic. So line magic we put into just one line. So for example, we can have a look at the p print, which stands for pretty print. And currently it's been turned off, so let's run that again. Now it's turned on again. And then I'm going to copy paste some code, which gives us a JSON file. And now if we have a look at the JSON response, we can see this looks fairly organized. But if we run this pprint command again, so now the pretty printing is turned off, then this looks horrible. And to give an example for the cell magic, here a really useful command is the HTML. So you write 2 percentage sign to indicate that we're using cell magic, then the HTML command. And now everything written in the cell will be interpreted according to this command, which will actually turn everything into working HTML code. So we can copy paste some code. And now we have a working HTML button. And if you want to make your notebook really pretty, then using HTML can prove to be very useful. But in this course, this is not something you have to worry about, just if you're interested and want to explore more.